both of these functions are just stating, like the demand function is just stating the law of demand, which says there is an inverse relationship between price and quantity demanded. Okay? That's why you have this minus sign here. It tells you if price goes up, quantity demanded will go down. And if price goes down, quantity demanded goes up. Similarly, with the supply function, so the relationship between price and quantity supplied, holding other variables constant. If price goes up, quantity supplied goes up. If price goes down, quantity supplied goes down. So here the question is asking us, determine the equilibrium price and quantity. Okay? So at equilibrium, quantity demanded equals quantity supplied. Quantity demanded equals quantity supplied. And also another side note, the price the buyer pays is the money that the supplier receives. Okay? So if you pay 10 kwacha for bread, the supplier is receiving that 10 kwacha. We're saying there is no government intervention. Okay? So this, especially this one, remember, is because when we add in, there will be some questions where they'll add in a tax or a subsidy, okay, and this will come into play. But for now, since there is no taxes, no subsidies, so the price the buyer pays is equal to the price the supplier receives. Okay, so all we need to do here is equate our demand function, 1000 minus 80p equals 20p. Okay. So we just have to find the value of p, which is our price. Okay, so it's a matter of algebra. So you can just say 1000 equals 20p. This negative 80p crosses over the equal sign, it becomes positive 80p. Right? Then you have 1000 here. 20p plus 80p, you get 100p. We get the value of p, which is our equilibrium price. We divide both sides by 100. 1000 divided by 100, you get 10. So that is our equilibrium price, 10 kwacha. Any questions, colleagues? Okay. So that's the equilibrium price. Now we're going to deal with the equilibrium quantity. Okay. So since you've got the value of P, okay, since we've got the value of P, all we need to do is we need to substitute this P equals 10. You can choose whichever function you want. You can substitute it in the demand function, or you can substitute it in the supply function. You get the same answer. Okay? So let me illustrate that you get the same answer. Okay, if you substitute it in the demand function, okay, P equals 10, you substitute it in the demand function, you have 1000 minus 80, you substitute P with 10, Okay, 80 times 10, that's 800. So you have 1000 minus 800. 1000 minus 800, you get 200. Okay, that's the equilibrium quantity, 200 units. Okay. So we've got the equilibrium price and the equilibrium quantity. As I said, if you want, you can substitute it also into the supply function. It's up to you to choose which one. You're going to get both correct. Okay. Our supply function was QS equals 20P. So P is substituted with 10. Times 10, that is 200 units. Any questions, colleagues? So we can illustrate this graphically. Illustrate this graphically. We have price here, we have quantity demanded. Okay, so this is how to illustrate this graphically. Sometimes you might be asked to draw this, okay? So you start with the demand function. Remember the demand function, QD equals 1000 minus 80P. Okay? So if we want to plot this, instead of making a table and start looking for values and taking long to plot this, all you do is this. Okay, and just say, when P equals 0, what is your quantity demanded? When P equals 0, what is quantity demanded? So you substitute P equals 0 into your equation here. Okay, QD equals 1000 minus 80P. So P is 0. 1000 minus 0 is 1000. Okay. So when P is 0, QD is 1000. So on your graph here, you just jot down 1000. Okay. Then to find the next point, you just say, when QD equals 0, what is the price when quantity demanded is 0? Okay, so our quantity demanded function, QD, you replace it with 0, so it says 0 equals 1000 minus 80P. Then take this negative 80P over the equal sign, you get 80P equals 1000. Get the value of P, divide both sides by 8. Okay. So when we say 1000 divided by 80, here on price, you're going to find 12.5. Okay. So you just connect the dots like that. Okay, that is your demand function. Any questions?
I wanted to find out something, especially for the second equation.
Okay.
Yes, it's just try to highlight exactly how you came about those. I'm understanding the equations, but there's just somewhere where I'm missing it.
Okay, just hold on some. Just going to. You are saying which part? Which part? Where did you want me to highlight, sir? Hello? Hello, sir? Hello, sir. Could you just repeat your question? I think I was kicked out by network.
Okay. For the second equation, the one that we have found 12.5, I wanted to just understand how
Okay.
you came about with these figures. Yes, yes, yes.
Okay. Here we are looking for basically where this demand line cuts the y-axis, where there's price, and how it cuts the x-axis, where there's quantity demand. Yes. So if you want to find these points, just since we've got two variables, QD and P here, so just equate both variables to 0 and you see which values you get. Okay. Yeah. So like here we started when price equals 0, meaning P in this equation we're going to substitute to the 0. Want to find what will be the quantity demanded. You just substitute this into the function, and that's how we got 1,000 units. Okay. Then if you want to find out when quantity demanded equals 0, what is the price? You also equate that back into this function here. So the key here is just equate P to 0 and QD to 0, so that you find both points that you're looking for.
Sir,
Yes?
in this always where you have to use a 0 or you can use any number.
You always have to use a 0. Because if you use any number, it will give you a point in the middle. Okay. You use 0. Okay. The long cut is this is the long cut. When you see in your books, you see at what they say demand schedule. Okay. You just start guessing numbers for P, okay, to find out what value of QD you're going to get. Okay, so for example, you say, okay, if P equals 1, you substitute 1 into the demand function. Okay. 1,000 minus 80 times 1. Eight times 1 is 80. 1,000 times 80, you get 920, QD equals 920. And you say, okay, when P equals 2, again, you just continue putting values of P and you start getting your quantity demanded values. But if you do this process, it will take you long for you to connect these dots here. Okay? So the shortcut is just equate P and QD to 0, so that you just make a quick line like this one here. Okay? I hope I've answered your questions, sir. Always use P equals 0 and QD equals 0 so that you make your line as quickly as possible. Okay. Yes. Any other questions? Now for our supply line, okay, since our supply line is sloping upwards like this, so we just have to find at which point is it going to cut the y-axis. Okay, so for our supply, since it's remember is QS equals 20p. Okay, so we're going to find out when QS equals 0, what is P? Okay, when QS equals 0, what is P? Okay, so 0 equals 20p. Get the value of P, divide both sides by 20. 0 divided by 20 is 0. So when quantity supplied is 0, the price is 0. So our supply function is starting from the origin here at 0. And then it just goes up like this. Since the supply line is not cutting the x-axis, that's why we haven't done when P equals 0, okay colleagues? The supply line is not cutting this x-axis, this horizontal line. That's why we only just did when QS equals 0. Alright? This is how you draw your curve. I mean, this is how you draw the curves. Okay? And we found out our equilibrium price was 12. What was the equilibrium price? 10 quatch. The equilibrium quantity 200 units. And that's how you draw. Start. Any questions?